Today, in this video, numerical and moment of inertia. Find the moment of inertia of a lamina shown in the figure about centroidal axis. This is figure, L-type figure. Find moment of inertia of this L-type figure. This x-x axis and y-y axis are centroid axis. See, L-type figure here. This bottom rectangular part consider 1 and B width of this rectangular part, bottom rectangular part 1 is 250 mm and depth is 100 mm. Now this rectangular part, top rectangular part, vertical rectangular part, consider it as a 2, width 100 mm and depth 300 mm. Sorry, depth 200 mm. 300 minus this 100, 200 mm. That means this to this distance is 200 mm. See here 200 mm, 100 mm. For finding this L-type figure, we use parallel axis theorem. This bottom rectangular part area is capital B into capital D. That means breadth into depth. Rectangular area. So A1 area is equal to this 250 into 100 mm. That means 25,000 mm square. And this L-type figure, top rectangular part is, that means two part area is 200 into 100. That means 20,000 mm square. Now, centroidal distance for this one rectangle is this. That means 100 by 2. Give name. Y1 is equal to 100 by 2. That means 50 mm. And Y2 is equal to 50 mm from this bottom part. See, 50 mm from this bottom part. And vertical distance, that means 100 by 2. Now next, this second rectangle, centroid, that means Y2 is this distance 100 plus 200 by 2. That means 100 plus 100, 200. This much total distance. 100 by 2 is equal to 100 plus 200 by 2. That means 100 plus 100 is equal to 200 mm. From bottom, from this part. this to this distance. Now x1 horizontal distance from centroid, x1 is equal to this horizontal distance for one rectangle is 250 by 2. That means 125 mm. And for this second rectangle, horizontal distance is 100 by 2, 50 mm. So area of first rectangle is 25,000 mm square. Area of second rectangle is 20,000 mm square. Y1 distance of first rectangle is, that means vertical distance, this distance up to this distance is 50 mm. Y2 distance, that means 200 mm up to this distance from this bottom side to this side. X1 is 125 mm. X1 is this, from this to this, from this side, this, and X2 is 50 mm from this side to this side. So calculate exact centroid of this L type section. For calculation of exact centroid, use formula x bar is equal to a1 x1 plus a2 x2 upon a1 plus a2. A1 is this x bar. What is this x bar meaning? This x bar is this from this to this side. This is x bar. A1 is 25,000 multiplied by x1 is 125 plus a2 is 20,000 and x2 is 50. So x bar is equal to 25,000 into 125 plus 20,000 into 50 upon 5,000, that means 45,000 is equal to 91.67 mm. That means this y axis situated 91.67 mm from this side. From this side, this y axis, vertical y axis is situated 91.67 mm. Now, how much distance this x axis situated from this bottom side is y bar. So calculate y bar. Y bar is equal to a1 y1 plus a2 y2 upon a1 plus a2. A1 is 25,000 multiplied by y1 is 50 mm plus a2 is 20,000 and y2 is 200. 20,000 mm and 200 mm divided by 25,000 plus here plus correct this x bar plus a2 is 20,000. Y bar is equal to 116.67 mm. That means this x-axis is situated from bottom 116.67 mm. See, this is axis for this 1 and 200 by 2. That means here this is axis for this 2. Give this axis name 1 axis name x1 and this axis name x2. For parallel axis theorem, use for this distance for second rectangle and for first rectangle use this distance. So moment of inertia about this x-axis calculate. Moment of inertia about this x-axis is equal to I x1 plus I x2. That means I x1 is first parallel axis theorem is moment of inertia about this I x1 axis, and moment of inertia about this I x1 axis is b d cube by 12. B is 250 into d is 100 cube by 12. 100 cube by 12 plus area of this first rectangle. A1 is 25,000 multiply by this distance between I x1 axis and for this section original axis is located at a distance 116.67 from this I x1 distance. Sorry, x1 distance. That means and this y bar is 1/6 at this distance. This red line vertical distance is, see, this y bar minus 50. Y bar is this total from bottom to this x-axis distance. Y bar is 116.67. That means from this y bar distance deduct this 50 mm, we get this distance. For yours, this is distance of y bar and minus this 50 mm, that this distance of y bar minus 50 mm, then we get this red distance x1 axis to x-axis axis distance for parallel axis theorem. That means 116.67 minus 50 mm. And square of this plus second, for second rectangle this distance is 100 mm. Here 100 moment of inertia is 100 into 200 cubed by 12 by 12 plus A2 is this 20,000 multiply by so see this x2 distance is this x2 distance is 200 mm from bottom, this much 100 mm and plus this 200 by 2, that means 100 mm, 100 plus 100 200 mm from bottom, and 200 mm minus this 116.67 mm is this distance. So 200 minus 116.67 and square of this distance for parallel axis theorem is, so 250 into 100 cube divided by 12 plus 25,000 into 116.67 minus 50 square, and this whole term is calculation of this ix is 337.50 into 10 raised to 6. And unit of moment of inertia mm raised to 4. So this is ix axis, this axis ix axis is moment of inertia is 337.50 into 10 raised to 6. Now next, moment of inertia about y axis. Iyy is equal to moment of inertia of one part, that means this first rectangle plus moment of inertia of this second rectangle. This first rectangle moment of inertia for IYY axis parallel to this YY axis. This YY axis side is, see here, this is YY, and parallel to this YY side is 100 mm. That means 100 as it is multiply by 250 cube by 12. Plus area of this A1 part is 25,000 multiply by distance from this YY axis. Distance from this YY axis to this axis here 250 by 2, that means here something here, this Y1 and distance from this much distance, is, that means 250 by 2 is here 125 minus this x bar distance. X bar is 91.67. 125 minus 91.67, 120, sorry, 125 minus this distance is x bar, this distance is x bar, this much distance, and up to this distance is 125 minus x bar, and x bar is 91.67. And square of this, for parallel axis theorem, square of this distance, this is I1 moment of inertia about bottom rectangular, one rectangle. Now for second rectangle, vertical 2 rectangle, YY axis parallel side is this, and this distance is 200. 200 as it is multiply by 100 cube by 12. Plus area of second rectangle, vertical rectangle is 20,000. Multiply by this is centroid of this second rectangle, and between this centroid and this YY distance, that means x bar minus 100 by 250. See here 100 by 2, this is 50 mm. That means 91, x bar is 91.67. This distance, total distance is 100 mm. and center of this second vertical rectangle is this. That means 100 by 2, 50 mm. That means this distance is 50 mm. And this y-axis, this dotted line is from this leftward part to this distance is x bar. This is x bar. That means x bar minus 50 mm. X bar is 91.67 minus 50 square. This is IYY. 100 into 250 cube by 12 plus 25,000 into 125 minus 91.67 square plus 200 into 100 cube by 12 plus 20,000 into 91.67 minus 50 square is 209.37 into 10 raised to 6. mm raised to 4. Between both Ixx and Iyy, Ixx is greater moment of inertia. That means this Ixx is greater moment of inertia as compared to this y-axis. That means load from this side to this Iyy axis is stronger. Greater load we should apply from this side. For this Iyy axis, if we applied perpendicular to Iyy from this side load, then see this L section deflect like this. But this Iyy vertical rectangle to acts like a compression. Thank you very much.